By the end of this video, you will be able to Dockerize an application and you will be able to optimize a Docker image to reduce its size and make it much more faster. So first of all, I have this app.py, which is basically a hello from Docker container, just a simple Flask app. And I have its requirements.txt, and that includes Flask. So let's get back to the repo. Now we need to create a Docker file. So let's create it. Name Docker file. Keep your D capital and everything small. Okay, after renaming, let's write the code. So before writing the code, first we need to understand what is our application about, so that we can decide the base image of our application. So right now I have Flask application. So base image will be for our Docker file. For this app, the image we can use Python. So let's type from Python 3.11 and slim. This is the base image. Base image means this is the line responsible for providing the environment to your application. That's it. Next, we need to declare work directory app. This line is responsible for setting the working directory inside the container. Okay, let's move to the next line. Now we need to copy the dependencies. So run the copy requirements .txt and dot. So we copy the requirements for caching, because caching can help us increasing the build speed. So this is why copy we used. And let's go to the next step. Now we need to install the dependencies before running the container. So let's type run and pip install -r requirements.txt. This install the Flask inside the container, because in the requirement.txt we have Flask. So in the container it is going to install Flask. And also we can use npm install space -- no cache dir directory to make it more better. Next, we have to copy the code from current directory in the base directory. Now expose the port on which we want to run the application, 5000. This line is responsible for that will help the container know on which port the app needs to be run. And last, we have command, the command we usually use to run the app locally, like Python and app.py. This will start the application. Okay, now I'm going to commit, and this Docker file is added. So now I will create an EC2 instance. So let's create an instance quickly because I can't run Docker on my machine. So let's name the server Docker lecture. That's it, leave it. And now we need to choose the operating system. I will choose Ubuntu server long-term support and prettier eligible t2.micro. Let's upgrade it to t3.medium. 4 GB of RAM, 2B CPU. Sorry. And let's create a key pair. It will be used to access our server. So let me give the name demo server and create. It will download a key. Demo server. Okay, save. Make sure in which folder you have saved the key. You know that. And another thing, we need to allow the traffic HTTP and HTTPS and launch. It is creating our instance, and we will install Docker on that and also Git, and we will run our app. So it is done. Let me see its IP. So this is the IP. I will copy it, go to my the folder where I have downloaded the key, open in terminal, and clear it once, ssh-i, and our key demo server.pem, Ubuntu @ and the IP. That's it. Yes. So we are inside the server. You can see. Now we will be installing Git. Sudo apt update to update all the packages, and then we will install Git. Come on. Okay, done. Sudo apt install git-y. Git-v. We have Git version 2.43. Let's install Docker. Install docker.io. Docker compose. I don't need that now. -y. So it is installing Docker on my server. Let's wait for it and check the Docker version. We have Docker version this one. Okay, so we have Git also. Let's go to our repo and select HTTPS, copy. Make sure your repo is public. If it is private, then it is going to ask the username and password of your GitHub account. So I will type git clone and the link. So it's done. Let's check. You can see demo app, and this is our content, Docker file, app.py, and requirement.txt. Now inside this, now I can run Docker build -d. We are going to tag it flask demo app and then dot. So this command will create Docker image. Hit enter, and I got some legacy rebuilder deprecated and will be removed in future release. Permission denied. Oh, sorry. I need to run the same command but with sudo. So it is creating our image. Warning. Okay. Let me clear it, and I need to type sudo every time. Sudo docker ps. No container is running. Sudo docker images. I can see my images. You can see. Let me copy the ID. Now I'm going to run docker. Let me use sudo first. Docker run port 5000 to access externally and internally port 5000 same, and the name of our app. Let me paste the ID and done. You can see serving Flask app, debug mode off, running on this IP. So first of all, let me check if it is accessible. Open a new browser, port 5000, and if port 5000 is not allowed, not in even server and not in the security groups. So let me docker ps. Oh no, sudo docker ps. What I'm doing, sudo docker ps. Oh, actually I stopped the container. First let me allow the traffic. Allow 5000 inside the firewall. Sudo ufw reload the firewall. Not enabled, so let's enable it. Sudo ufw enable. Yes, it can disrupt. Okay, firewall is active and enabled. Now check the port if allowed. We have this one allowed and this one. Make sure you allow port 22 as well. Otherwise it is gonna disconnect you and you will not be able to SSH into your server. That's the different thing. And I will also create a video on what if you are not able to SSH into the server, even your ports are opened, then how can you recover your SSH access? I will create a video on that. So let's reload it first. Sudo ufw reload. Reloaded. Let me go into the security instances, and I need to check the security group. It is running. Security. Go into the security. Let me open in new tab. and we need to allow the port 5000 in the security group. Edit inbound rules, add rule, custom TCP 5000, allow from anywhere, and save. That's it. So it is updated. Clear sudo docker run it for interactive terminal dash p port 5000 and our app name flask demo app, sorry, image name, and now it should run. Okay, you can see it is running, and I need to go to my browser, and you can see hello from Docker container. It is running. So our app is running. Now let's discuss on how we can more optimize the app. So let me stop the container. Okay, and go to the GitHub repo. Make sure you always have a Docker ignore file. Let's create it. Docker ignore. This tells the Docker what things to be ignored to avoid the large size of the image. Unnecessary things we can include here, like PyCache and something with extension PyCache .git as well. We don't need that in Docker image, and .env because we should pass the credentials during the runtime. So that's why we are ignoring it here. .env and commit the changes. So unnecessary files will not be included in the Docker image. Now, okay, let's talk about the Docker image optimization. Okay, now problem in this image is that it is going to pull the full Python image. So large image is going to be formed, and no caching optimization copies everything too early. No Docker ignore. We have added Docker ignore, and the dependencies installed every time, causing the build time to increase. So let's try optimizing it. So we have already used the image slim instead of full Python image. That's okay. It will result in smaller image and faster download and deploy. And the next step, we have work directory. Okay, leave it. And this is the thing, copy requirements.txt. We have not written like copy dot dot because this command is going to install the not install, it is going to copy the entire project. Even you have changed only single file, but this is going to install the sorry, I'm not saying install. It is going to copy the entire project. So that's why we need to write requirements.txt instead of dot dot. In the next line, we need to remove this one. So it's It will install the requirements. Now I'm copying the requirements.txt so Docker can cache dependencies, and if I only change some code, dependencies is not going to install again. So I have removed the no cache directory because this will prevent pip from storing unnecessary cache files. That's why I removed that line. We are telling pip not to store unnecessary cache files. Thus, it will help reducing the image size. And we already have included the .docker ignore in our project. That is a great thing. It will help us avoid sending unnecessary files to the Docker, and our build is going to be faster and much more cleaner. Now for Python, this is minimal. Now we try to reduce the layers because in the Docker file, every line creates a Docker image layer. So we try to combine the commands when possible. Okay, now we need to add user for security, but that is a different thing. By default, because containers run as root, and running the containers as root is not safe. So we should create non-root users. We will create another video on this. So this is the final optimized image, and sorry, why it is going to cache the things. So use this one. Sorry, we need to use it to avoid caching. To avoid, okay. That's it. Let's commit the change and done. Now it will reduce our size. The build will be much more faster and much more cleaner. So optimization in Docker is mainly about three things. First thing is that we need to reduce the image size. Second thing is that we need to use the caching properly. And third thing is that we need to improve the security. Security point we will consider later in another video. So now we have done it, and okay, also I need to stop the server. So let's exit it, exit, and let me stop and remove the server, otherwise it will cause builds. So let's instance state, terminate. I want to skip the OS shutdown and terminate. It is going to delete the instance, and I will be avoiding the builds. If you got some points, if you got some knowledge from this video, then please like, share, comment, subscribe, and you can visit my website, the DevOps right.in. This is my website where you can find contents, my social handles, and notes, and some tools, and you can contact me here. That's it. Thank you guys. Thank you for your time. Catch you later.